to execute that set of instructions. Okay. So what the person can do is first he can just sit down, look at the set of instructions, and then see if there are any inconsistency in the set of instructions that you have given to the person. If there is an inconsistency, he will point it out. Sir, there is a problem. Suppose you want him to go from A to B. Your first instruction is go from A to B. The next instruction is go from C to D. Okay. Then he'll be confused when he is studying your set of instruction. He'll be confused. He'll say, "How do I go to C then? If you ask me to go to A to B, and next you are asking me to go to C to D, then how will I do that?" So he'll come back to you and say, "There is a problem in the set of instructions that you have given." So this is what this is a compiling. This is what compiler does. It basically looks at the set of instructions, checks its consistency, etc. Okay, if it's consistent, then it will proceed to perform those steps. Okay, that is as simple as that. So that is the compilation-based languages like C, Fortran, Pascal, or Java, etc. Okay. Now there are other class of languages which are script-based languages like Python and the MATLAB. Okay, so these are basically languages where it's going to perform each step at a time. Okay, so you give him set of instruction, go from A to B. So he'll just look at the set of instructions that you've given, look at the sheet, and then just go from A to B. Then he'll see what is going to be done next. So the person is not going to sit there and first analyze the set of instruction and then proceed to execute them. Okay, so that is kind of unintelligent execution of the steps. Okay, so that's where that's a script language. Okay, but it's both of them have their own advantages. So script language, you have to be careful that don't your instructions should be consistent step by step. You have to take care of it. In case of compiler based languages, compiler takes care of the consistencies in the set of instructions. All right. So MATLAB is essentially a script based. So it's basically you give an instruction, it will perform. Okay. All right. Now, okay. Now, how to give the instructions? Okay. So how to issue the instructions? To do that, if so, to do that, there are two ways of doing it. First of all, you can do it from the console window. This is my console window. Okay, you issue a command here, and this is a prompt. Two greater than equal to sign together. This is a prompt. At the prompt, you issue a command, and it will basically execute it. Okay, but suppose you want there are some set of commands which you want to give repeatedly. Like there is some there's a set of instructions. Okay, and you want your computer to perform those set of instructions in one go. Okay, then what you can do is you can actually store those set of instructions, all right, in a file. Okay, that file will be called script file. Okay, so that is .m. Okay, that's called .m or script file. Okay, so in case there's a script file. Okay, so you can actually either run it through. You can maybe I can write it like instructions to be run either through console, okay, or to script file. Okay, so there's a bunch of instruction that contains a bunch set of instructions. Okay, that is what you call a code. Actually, contains a set of instructions. Okay, so it will have probably step one, step two, step three, okay, etc. Okay. So this will be stored in a single file, and that will be .m file. So that will have a name given as file name .m or something. Okay, and as far as I know, the same kind of approach is there in Python also. So if you know Python, will be very easy for you to actually work with MATLAB, or vice versa. Okay. All right. I think in that sense, since Python is such a so much sought after language these days, so I'll recommend that you learn either Python or MATLAB. Here you have a reason to learn MATLAB so that you can easily switch over to Python later if you want. Okay. All right. So this would be basically all these set of instructions are saved in a file called filename.m. Okay. And when you click on this file name will appear. Okay, this file name will appear over here. Okay, should appear over here. This should be in your current folder where you're working. Okay, and then when you click on any of these files, okay, that file will open. So for example, here I have a bunch of files. Let me say I open a file. um, so let me say I open a file. That's the first one I'm going to open, fdderivs.m. Can you all see this? Can you all, are you all able to see the MATLAB window and this derivative FD derivs file? Can you all see this? Okay. All right. So what we can do, for example, if I just double click on this fdderivs.m, this will open up. This is a .m file. It's an example of a kind of MATLAB file, and it says function. Okay, it starts with a function. It's a function file. I'll tell you what is a function file a little later. But this is one kind of MATLAB file. Okay, let me close it now, and now uh, okay. I will come back to it later. But let's see. Just a second. Yeah. Now we'll go back to that. What is a script file versus what's a function file? Okay, but they both fall in the same category of MATLAB file. They both end with .m. Okay, script file will. So let me start with first issuing command on a console window. Okay, that is this over here. Okay, now so a lot of things I'm going to skip. I'll just tell you the things which are important for you. So first thing is, if you're C or Fortran or Pascal, okay, there you need to, for every variable, remember it's a compiler based language. So you have to issue an instruction that, okay, I'm going to use a variable named X, which will be a real variable. Okay, so in these compiler based languages, you have basically to define a variable and declare a variable. Definition and declaration are important. Okay, of a variable. Whereas in this case, in script language, you don't have to do that. So this way, although it's less intelligent in the sense that it cannot spot the consistency of the set of instructions, but it's more user friendly. So this kind of approach is very popular because it's very user friendly. Okay, so user friendly. Okay, it saves a lot of time. Okay, so so going back to, let's say, the MATLAB window. So it does, you don't have to define or declare a variable. All you need to do is just issue a command. Let's say I'm going to issue a command like x equal to 3. Okay, so now it automatically takes, it automatically, what it does is it creates a variable x, which is a real number, and stores a value 3 in its name. Okay, so if I enter it now, so when you enter it, it displays something which is x equal to space 3. Okay, so this is an answer. So what is done, what has it done now? It has basically defined a variable called x. Okay, and this is a default response. This is a default response. Okay, look at this window. If you look at a window which is over here, um, okay, here you can see that this is the name X and the value appearing here. So this window is a workplace window. It basically lists down all kinds of data variables over here, and it's whichever. So this basically this I should say this sorry. Um, so so this window is this basically you can say this is a this window displays all variables currently in use. Okay, in use. And whereas this window which I'm going to write now on, this is a window where you issue your commands. Okay, all right. So now if you do so there's a default variable called answer, default variable called ans, that is inbuilt variable. You are not supposed to define a variable of this name yourself. Okay, this is something that MATLAB has reserved for its own use. Okay, so for example, if I just write, if I just plot, if I just write down and the if I just write give a command ans, okay, over here in the prompt, uh, so that's the answer. That is what x is actually. Okay, it's not showing it probably, but so if you just put x, it will display the value of x. Okay, and that is stored in an ans also. Okay, so okay, so now what kind of variables we are going to use here in our exercises will be very frequently be concerned with vectors and matrices. Okay, so that is very important for us to understand about use of vectors and matrices in MATLAB. Okay, all right. So how do you do that? So a vector, as we already know, okay, a vector is a set of or set of numbers. Okay, so vectors can be stored. Vectors, which are a set of numbers, okay, they can be stored in two formats. Okay, one is row or column. Okay, so you can have a row vector or a column, same information. Suppose I have a force of xi 2i plus 3j. Okay, then you can store it. F is, let's say, 2i plus 3j plus 5k. Okay, I'm going to store this information for the purpose of processing it further in MATLAB. I can say that f can be written like this, or f can be written as well as, okay, like a row or a column. Okay, both are permitted, or depends on how you what you do, how you use it. Okay, now, so how do you construct a vector? So constructing a vector, let me just give an example. So constructing a vector would be okay, so constructing a vector, let's say I'm going to construct a vector v, okay, which has value 1, 2, 3. So v equals to, starts with a square bracket and then entries. All the entries should be separated by a space 3. Okay, now I enter it here and then just give a command and then enter. Okay, When you hit enter, it's going to echo back the value that you just assigned. And you can see in your workspace window over here that a new variable has been introduced in your list called v, whose value is 1, 2, 3. Okay. If I had to define a vector, the vector, same vector v, in form of, let's say, in form of a same vector 1, 2 as a column vector, then the command that I'll give v equals to square brackets, and then each entries will be separated by a semicolon. 2 semicolon 3 enter. Okay. Now if I hit enter, I'm going to hit enter now. So you can see that V echoes back this answer V that you've just assigned. Now it's going to look like a column vector as shown up here, right? Can you all see this? So this is your column vector. Okay. Rather than as opposed to the row vector as shown up here, it appears as a column vector. Okay. All right. So this is your this is your vector construction. Now, how about vector operations? Okay. So vector operations. Maybe let me just use this now, and let me talk about vector operations. Okay. So how do you manipulate these vectors? Once you have defined a vector, how do you manipulate a vector? So let's say I have um, to manipulating a vector. What are the vector operations that we can do? Manipulating vectors, or basically vector operations. How do you perform vector operations in MATLAB? Okay. So adding and subtraction are very simple. Okay. Only thing is that you have to make sure that you're adding column to column vector and row to row vector. Okay. So for example, let's say, and by the way, it's always advisable to keep trying different things yourself. Okay. So if you are in doubt, just check it yourself, right? So for example, here, let's say I'm going to define a vector v. V is already defined to be a column vector as over here. Let me define a vector w equal to a row vector. Okay, like this. Now w is this. If I issue a command w plus w, you're going to get something looking strange. See that? So we'll come back to this. So what I wanted to do, so maybe I can redefine w to have some different numbers. So if you just press up key, you'll repeat the previous commands. Okay. So pressing up key. So let's say it's 4, 5, 6. Okay. And then enter. And then if you say v plus w, I'm going to get matrix actually. It's not a vector. Adding two vectors should give you a vector, but you're getting matrix. That is because the two vectors are not of the same kind. One is a row vector, one is column vector. Okay. All right. Has actually done is, I'll tell you what it has done. But at the moment, let's say I wanted to add these two vectors. How I'll transform this row vector to column form or v vector to a row form. Then only I can do that. So the way you do switching from row to column vector is by transposing them, right? So row. So when you have a row vector and I take a transpose of that, that will give me a column vector. Okay, so that we all know, right? So that's what transposing means. So now here, for example, if I give, and how do you transpose in MATLAB? That's given by just issuing prime on a vector. So v prime, if I just enter here, now you see v was a column vector 1, 2, 3. Now it appears like a row vector here. So now if I just give v prime plus w and then enter, I'll get the sum of those numbers 1, 2, 3, and 4, 5, 6. I get 5, 7, and 9. Okay. Or you could have done v plus w prime. That will result into a column vector, but it's consistent, and same 5, 7, 9 appears like a column vector. Okay. Okay. So this way you can do addition and subtraction. How about products? So now there are two kinds of products. We know cross products and dot products. Okay, so let's look at so dot product of two vectors. Okay, so dot product of two vectors. So let's say dot product of two vectors. What you need to do, for example, suppose I had to take the same vector v and w. Okay, I had to take a dot product of these two. Now there are many ways of doing it. So now one way of doing it is a using this operator called star operator. Okay, so we have two vectors v and w. So v star w will give me dot product. Okay, so now let's just issue this command and see what happens. Okay, so v star, and I'm not getting a dot product, actually a single number. I'm getting a matrix. Okay. However, if I do this v star, there is a problem. Okay. What does it say? There's a dimension. There's incorrect dimensions for matrix multiplication. All right. So w prime or either way, if you give v prime, so any error will actually appear in red color, right? So v prime starred with w. Again, I have an issue. Okay. So what is going on here? So dot product is actually so remember when you take dot product, how do you perform dot product? So well, if you have a row vector, you have to ensure that the matrix. Sorry. So you have to ensure when you take dot product, you have to ensure that the dimensions of, so remember column vector and row vector can be thought of as a matrix of n by 1 by n uh, rows and columns, right? So these dimensions in order to have, so for example, I can take dot product of these two vectors where this is 1 by n and this is n by 1. That will give me a single number 1 by 1. Okay, or I can, so this is visible. However, this is not just, if I had to do this way, if I had to do it like and this is not permissible. Okay, this will not give me dot product. Okay, so you have to ensure that you have to multiply a row vector with a column vector. So now let's say what was my row vector. Let me recall. So in my notation, in my definitions, v, if I just, v is a column vector and w is a row. Okay, so now if I give w starred with v, I should get a number which is this. Okay, if I gave v star w, there was an error. Actually, there's not an error, but it does not give, it gives you something else. Okay, and if you have two vectors, so other possibility is like you take a dot product of either, so there are three possibilities, well, four possibilities actually. One is as this one, which is the correct one. One is not a dot product, but something else will happen here. Okay, this will form a matrix actually. If you give it in this form, this will form a matrix. So this is basically, so if you give this way, this will be VIWJ kind of matrix, which is AIJ. So it's basically looking at multiplying term by term. So one, so if you give it this way, it's going to multiply this with this. I get first number, this with that, second number, third and fourth. Then again, it will change the row. From here to here, that another row, this into this, another row, this into this, another row, another column. Then again go here, third row, first column, second column, third column. So this way, it's going to proceed with the two entries here, and it will construct a matrix which would be the size of n by n. Okay, and these entries are given by this. So that is what this operator, star operator, would do if their if their this thing are not matching. Okay, right? So one, it's not one by, if this one by n, and this is, if this is not in this format, then we're going to get a matrix. However, there are two more options, which is if you give this star of this form, this this will be an error. Okay, and similarly, two column vectors taken dot product, taken star dot, using star operation on two column vectors. Okay, so that's what we were actually facing here. Okay, so let me show you again. V is my column vector. So let me say V, if I give V prime is my row vector starred with W, and I have an error. Or if I take W prime, okay, W prime, which is now a column vector starred with V, I should get an error. Okay, so these two cases will give you errors. So you have to be careful when you are using star operator to find your dot products. Okay, you have to make sure that your order of the vectors which appear with respect to the star operator, that has to be correct. Which is first, which is second, and what are their shapes? That has to be consistent. That is the first thing. However, there are, so now it requires you to have to keep track of their shape, how many rows and columns are there, okay, or whether the vector is a row matrix or a column matrix, or row vector or column vector, right? Which comes first, which comes second. You have to keep track of that. However, you can basically forget this concern by using a by using very simple something known as function, and we'll come to function later. But there's some inbuilt function in the MATLAB, and one of them is called dot. Okay, so this you just use dot, okay, and then give your V and W, no matter what shape, what which one, whether it's a row vector or column vector, doesn't matter. It will give you the answer, correct answer. So it automatically processes it so that they are consistent. So there's an inbuilt function inside uh, inside this MATLAB. So dot is this is an example of something known as function. And what is a function, we'll shortly discuss. Okay, so this function, every function will you all know that, well, basically you all know that every function achieves something given some input. So it's a like input output thing. You give an input, it gives you an output based on certain instructions. Okay, so here the inputs are these two vectors V and W, and the functions are always will have a function name. Okay, function, and then brackets, small brackets, and then set of inputs here, input 1 and input 2 and so on. Okay, all right, so you all probably know this, but I don't know all of you remember this or not, but anyway, so this is the typical syntax of a function, or typically how the function is referred to or processed. Okay, now there are some inbuilt functions in MATLAB, and there can be uh, functions you define. So they can be user defined functions. Okay. This is an example of inbuilt function dot. Okay, you're not permitted to define a function of this name. Okay, all right. So now let's move on to matrices. Okay, before that, okay. So before that, now let's say I have to find. So there is something also called element by element operation. Okay, so something as element by operation on a vector or a matrix. Okay, we'll come to matrix later, but let's just illustrate it for vectors. Okay, so Well, so suppose I had this vector. V was what? What was V? Let me recall. If I just want to recall, I just type V and enter. I get a column vector. So V is a column vector. Now suppose I wanted to find. I wanted there was some operation. There was some part of my calculation required each element to be squared. Let's say I want to form a new column vector which is 1, 4, and 9. So this is like element by element squared. Okay, this is not. This is if we call this V. Okay, and let's call this. So this is not actually V square. Okay, this is element by element square. So this is not should not be referred as V square. V square is essentially Vi. Is basically V square, as you all know, V1 square plus V2 square plus V3 square. Okay, that's a scalar. Basically, this is nothing but V dotted with V. Okay, all right. So if you have to find V dot V, okay, that's a single number and which is not equal to what I have just shown up here. Okay, all right. But lot of calculations often involve performing element by element operations. Okay, same kind of algebraic operation you may require to perform on each element. Okay, so for example, here I am squaring and I'm squaring each term, or I'm taking exponential of each term, or I'm taking logarithm of each term, sine function of each term, and so on. That's a possibility, right? So to deal with such concerns, okay, what one can do is, for example, you can actually perform step by step, element by element operations. So, for example, that is done by using a dot next to your uh, defined variable. And so I'm going to square this. That will be v dot square. Okay. If I just give v square, let's see what happens. There's a problem. Okay. It does not accept v square. Okay. Because v square does not mean anything. If I just give v star v, will it make a difference? Will it be acceptable or not? You answer me. Can anyone answer me? If I have, okay, what is v? There's some, yeah, there will be an error. You're right. So Satvir, you're right. Satvir, there's someone who's asking, uh, this is cross product. No, this is not cross product. No, this is not cross. Which is, what is cross product? I'll come to you, Satvir, just okay. And there's another question. Rohit, you're asking V prime star W prime. That will be a problem also, I think. Let me just go one by one. So let's. My claim is this should be an error, and that's an error because I am taking V and V are the same column vector. So they're not consistent. Therefore, there's an error. Okay. Now V prime W prime will also give me an error. No, no, I think that's correct, right? V prime. So now if V prime is W, right? So V was a column vector. When you define V prime, this becomes a row vector. Okay, so that's correct. So yeah, so V prime dot W prime is correct. So if you take V prime, that will become a row vector, and W prime was a column vector. Now it becomes row vector becomes a column vector, and then these two are consistent. So that is giving me a correct answer. Okay, that's fine. Okay. So, okay, and all right. So we okay. Now what else? What were we talking about? V star V ho gaya. Okay. Now, so now if so square would have required you to do V. If I wanted to V square like what we do, okay. That is V1 square plus V2 square plus V3 square. You have to have V starred with no, this will not also work. V prime starred with V. That should work. Okay. So this would be, if I give V starred with V prime, there would that be a problem because that would give you a matrix instead, right? For the reason we have just discussed. Okay. So I hope this part is clear to you. How to what is the what how do you perform this star operation, all right, and how do you calculate the dot products, and there's additional operation that is permitted here is you can also construct a matrix, okay, which is given by, basically, if you do element by, if you just if you have vector A and vector B, okay, which are row and column, okay. So for example, let me just say, let's just say it here. So let's say V1 is 1, 2, 3, and V2 is 4, 5, 6. Okay. If I give a command like V2 start with V1, okay, this is basically 5, 6, 1, 2, 3. Okay. Now it's going to give me 4 into 1. So that will be matrix 4 into 1. So I'm going to multiply this into this into this into this. Okay. Then again this into this into this into this. Then this into this into this into this. That will give me 9 terms arranged in 3 rows. Okay. 4, 8, 12, 5, 10, 15, 6, 12, 18. Okay, let's check this. So, oops, oh my God, just a second. Just a second. Let's continue. I have trouble with my battery today. So this class I'm going to end earlier than other days, but I'll cover up. Okay, I'll probably extend other class because I'm not carrying the charger today. By mistake I forgot it, and my computer is out of battery now. Okay, sorry about that. Let's continue until whatever time we can continue, and we'll switch off. So, okay. Oops. Oh God.